Example G. Given maps of f and g, create a map of the composite function f of g of x. All right, so first we're going to begin with our input values for g, -1, 0, 1, and 2. Then we're going to list all of our inputs for f, 0, 1, 2, and 3. So let's look here. -1 maps to 2, and 2 is an option. So -1 does map to 2. 0 maps to 0, so we can map that up there. 1 maps to 2, so that can go like that. 2 maps to 4. 4 is not an option, so we're going to eliminate 2. Also, we can see here that 1 and 3 aren't used at all, so we can eliminate those. So then we get our outputs over here. -1 maps to 2, -1 goes into 2, 2 then goes to 8. So we can put 8 there. If it ends up at 2, we'll end up at 8. If we plug 0 into f, we will end up at 2. So from our inputs over here, we have -1, 0, and 1. We can possibly end up with 2 or 8. If we have -1, that will end up at 8. If we have 0, that will end up at 2. And if we put in 1, that will end up at 8 as well. We'll go over the domain and range on the next slide. So the domain becomes these numbers here, -1, 0, and 1, the possible inputs. And the range are all of the possible outputs. And we're left here with just 2 and 8. Example H. Given maps of f and g, create a map of the composite function g of f of x. So first, let's start with all of our possible f inputs, which are 0, 1, 2, and 3. Then let's make a little bubble here of all of our possible g inputs, and those are -1, 0, 1, and 2. So now let's see if any of these map to any of these. So 0 maps to 2, so yes, we can map that there. 1 maps to 5. 5 is not an option, so we're not going to have 1 in there. 2 maps to 8. 8 is also not an option here, so 2 won't work. 3 maps to 11. 11 is not an option, so 3 also won't work. So the only value here that will work is 0. So all of these go away. And if we do get 0 for f, and we get an output of 2, that 2 gets plugged into g, we'll end up with 4. So the domain is just 0, and the range is just 4. And here's a nice looking map that demonstrates what we did on the previous slide. 0 is the only value that maps from f to the inputs in g, and then when you have 2 here, that maps to 4. Therefore, the domain is just 0, and the range is just 4. Example I. Given the graphs of f and g, complete the table of the composition g of f of x as an aid to your inquiry. All right, so when x is -2, f of x is 2. G of 2 would be when x is 2, g of 2 is 1. So all we have to do is take this value and plug it into g. When x is 1, g is -2. When x is 0, g is -3. When x is 1, again, we also have -2 again. 2, we already figured that out. That would be 1. And at 3, g of 3 does not exist, so this one does not exist. Let's do domain and range on the next slide. Okay, so the domain of g of f of x is going to be all of the values of f of x that do map to values of g of f of x. We have -2 all the way through +2. From here to here. They have values that when you plug these x values into f of x, we get these inputs, and these map to outputs. You can see here that 3 does not map to a value in g of f of x, therefore we cannot include 3 in our domain. So from -2 to 2. The range is going to be from -3 to 1. Those are all the values here, from the least to greatest. So -3 is the least, positive 1 is the greatest value. From here to here, you can see that those are the y values that line up with the graph of g. So yes, our range of g of f is going to be -3, 1. Example J. Given f of x equals x squared and g of x equals the square root of x, determine a simplified formula for f of g of x, including the domain and range of the composite. All right, so f of g of x would be f of the square root of x, since g of x equals the square root of x, and that would be the square root of x squared, or x. For this one, g of f of x, we have g of x squared, and that would be the square root of x squared, or the absolute value of x. On the next slide, we'll go over domain and range for both. Okay, so since the input for the first one included square root of x, that means that all of the inputs have to be greater or equal to 0. So we have our graph of x here, but only the part where x values are greater or equal to 0. So the domain would be all real numbers that are greater or equal to 0, and the range is going to be the same, all real numbers that are greater or equal to 0. Down here, we have the answer is the absolute value of x, where x could have been positive or negative, so it looks like this. The domain is going to be all real numbers, and the range will be all numbers greater or equal to 0. To determine the domain and range of composite functions takes time and careful analysis. Here are some guidelines. The domain of the inner function must be honored to start. The inner function's range becomes the outer function's domain. It too must be satisfied. In honoring this, the domain of the composite may have restrictions beyond the inner function's domain restrictions. You may want to use a map, a table of values, or a graphing utility like Desmos to aid your inquiry. In short, it is not a simple matter.